Hi guys, welcome back today. So on this same question, October, November 2023, paper 4, we have solved question 1 in the previous video. So today, I will walk you through on solving question 2, so which is on Q. So while teaching this, I will need to explain what a Q is and how we work with a Q. The question states, a linear queue is implemented using the 1D array queue. The index of the first element in the array is 0. So write program code to declare queue, a global array with space to up to 50 IDs of type string, head pointer, a global variable to point to the first element in the queue, which should be initialized to -1, then tail pointer, a global variable to point to the next available space in the queue, initialized to 0. So remember, these are global variables, so let's write that. So we need to declare Q as a global variable. Then we type global, then Q. So you have to put it in the comment that a global array of type string um, with space up to 50 IDs with 50 spaces. So that is our variable, so you have to write the comments to declare the variable. So head pointer points to the first element, that means head pointer is an integer. So also write global head pointer, so which is an integer. So you declare it as an integer. Then tail pointer is also a global variable which points to a space, so that means tail pointer is also an integer. So global tail pointer, which is also an integer. So these values have been declared. So the first thing to do is to make Q, to declare it as a list, okay, because it's an array. Then we have to put it in initialize with an empty list. Head pointer is set to be -1, so head pointer is equal to -1, and tail pointer is equal to 0. Tail pointer equals to 0. So head pointer points to the first element in the queue. So this points to the first element in the queue, while this points to the next available space according to this question. Okay, so points to the next available space. Okay, that has been answered. So the next question now says a procedure in queue takes a string parameter. So it's a procedure, so I have to write as a function in queue takes a string parameter. So let's call that parameter and let's call it word. Let's just call it word. It takes a string parameter. If the queue is full, the procedure outputs a suitable message. If the queue is not full, the procedure inserts the parameter into the queue and updates the relevant pointer. So let's understand what a queue is and how do we work with a queue. So that is the first thing we need to understand now. So a queue is just like a memory location. It can be visualized this way. Okay, just a memory location. So we can use an array to represent this. So a queue is not an array, It is just a representation. So we can use that to represent a queue. Now, for this queue, this is this position as is the first position, right? So this is index 0, 1, 2, 3, 4, 5, 6, 7. So there are 7 spaces in this queue. In the question we are trying to solve, it states there are 50 spaces. So let's work with this small space so that we can understand what a queue is. So if you go back to the question, it says that the head pointer points to the first position, right? The first element. Head pointer points to the first element. Is there any element in this memory location? There is no element. So that means head pointer will be equal to -1, which is exactly what we are asked to do here. So to be equal to -1. So tail pointer points to the next available space. So the next available space is this position. Okay, so that is the reason why tail pointer was told to be initialized to 0. So this will be the tail pointer. So that means this is what? This is the tail pointer. Is this understood? So that is the head pointer and the tail pointer. So the maximum size of this queue is 7 in this illustration, but the maximum size for the queue in this question is 50. Is that understood? It's 50. But for this illustration, it's 7, so that we can visualize the illustration. So if you want to enqueue, you want to add data to this queue position, to this memory location. Let's assume we want to add 5, 15, 20, 10, and 3. Okay, let me just add 4 things. So adding data to this memory location, that process is called enqueuing. So we are adding data to the location. So if you want to enqueue, where do you add the first value? You add it to the first location, right? Why are you adding to the first location? Because you can see that it is empty. But what if you don't know if it is empty or not? You can't see it. You have an array that you don't even know if it is empty or not. So the first thing to do is to check if this is what? If this is empty. If the queue is empty. So that if it is empty, you can place 5 to this location. And besides, what is a queue? A queue is just, it can be described as first in, first out. So let's take for example, you have a door, okay, and people are queuing, people are on queue to get attention or maybe to get a service. So this is the first guy that gets to the queue. Is that understood? So he is also the first that will be attended to. Is that understood? And he leaves first because he's the first guy to be attended to, then the second, then the third. So you can see that this guy came in first and is leaving first. So that's why we call it first in, first out. This is a queue. You can also see that in your printer when you are printing your file. If you send 5 files to your printer, when you get to the printer, you see your file arranged in such a way that the first file is at the top, the second, the third, the fourth, and the fifth. So when you start printing all your files, you realize that the first one will be printed first, followed by the second, third, fourth, fifth. Is that understood? So this first file that you sent gets out first before the next. So that is a queue. So a queue is a first in, first out. So to add this 5, we must add this 5 to the first available space that we can see. But because we can see this, we know that the space is 0. But what if we can't see it? So we need to write an algorithm to check if the first position is occupied or not. Do you understand? Because when a guy comes in and wants to join the queue, he can't just come to this first position and join. No. There's someone there. So he needs to join the next available position. I hope you understand that. So that is what a queue is, and that is the best way to visualize a queue. I hope you guys understand that. So let's come back to this point. So the first thing to do is check if what? If the queue is empty. That is the first thing. So if you check if it's empty, that tells us whether to add it here or to add it at maybe at this point or at this point or at this point. It tells us if we are adding at the first position or not. Then the next thing, we need to check if the queue is full. Because if this queue is full, where do we want to add 5? There is no space to add. So we need to check if it is full. I hope you understand that. We need to check if it is full. So to check if it is full, this queue will be full if there is a value here, isn't it? And since this question states that tail pointer points to the next available space, So the next available space is, if this is filled, the next available space is here, out of this queue. So that means to check if it is full, the tail pointer will be greater than 7. So if tail pointer is greater than 7, that means this queue is full. So to check if it is full, then we say if TP means tail pointer is greater than max, where max is the maximum value of what? Of this array. Is that understood? So that means we have to say max is equal to 7. So for this question, the maximum value, the maximum the maximum index for this array is 50. So it should be 6, not 7. Okay, greater than 6, not 7. Since the maximum value in that question is 50, then it will be 49. Why is this 6? Because, okay, so yeah, sorry, 7. I'm sorry, 7. So 7 is correct. Okay, 7 is correct because the position is what? 0, 1, 2, 3, 4, 5, 6, 7. It is the length of this that is 8. Okay, so but for that question, the length is 50. So the maximum index will be 49 because total length is 50. Total length of this space is 8 from 0 to 7. So to check if it is filled, so we have to check if tail pointer is more than the maximum point, which is 7. So if it is more than the maximum point, then that means the queue is what? Is filled. I hope this is understood. That means the queue is filled. Else, we still need to check if the first position is filled or not. So that if the first position is filled, then we'll put data at the next available space. That is, if this is filled, we put data here. If this is not filled, that is where we'll put the data. So to check if the first position is filled, we need to check if the head pointer, okay, or we can also use the tail pointer, is equal to 0. We need to check if tail pointer is equal to 0, because we said that tail pointer is equal to 0 if this is empty. That means it's pointing to nothing because tail pointer is pointing to the next available space. I hope this is understood. So tail pointer will be equal to 0 if this queue is empty. So if it is empty, so that means I need to place my value, this 5 value, in the first available space. So first available space, don't forget that head pointer is what? Head pointer is -1. Then I increase the value of head pointer to be equal to head pointer equals to head pointer plus 1. Then I say that array of head pointer is equal to that value 5. Is that understood? The first value. I hope this is understood. So that it is placed at that position. If I didn't increase the value of head pointer, it put it at array of -1. And array of -1 does not exist. The first index is 0. I hope this is understood, which is the reason why I need to say head pointer is equal to head pointer plus 1. So now this value, this index is now the head pointer, right? Then this index should now be the tail pointer. Pointer should no longer be here because tail pointer should point to the next available space. So that means that tail pointer should be equal to tail pointer plus 1. So that tail pointer is now the value at the next available space. I hope this is understood. So that is what this else statement does. Now the value has been added. So if you want to add more value, how do you add more value? You want to add 15, for example. If you want to add 15, what is the first thing? Is check if what? if the queue is not empty. So since the queue is not empty, sorry, it check if the queue is not filled. Okay, since the queue is not filled, then it checks if what? If the queue is empty. This checks if the queue is what? Is filled. This check if the queue is what? Empty. Is that understood? So if the queue is not empty, of course it is not empty because we now have 5 at this position. Is that understood? Since the queue is not empty, that means else. That is if the queue is not empty, because it can't add it to that first position. If the queue is not empty, that means the first position has a value. Now else, then that means that the array of that position, and the position is what? Tail pointer, will be equal to that value. So that means that this is the tail pointer index, okay, then it equals to 15. If this is equal to 15, then the next available space should be the tail pointer, no more this, okay. Then we write that tail pointer is equal to tail pointer plus 1, so that the next available space is now there. I hope this is understood. Head pointer will not be affected because head pointer only points to the first item. Is this understood? Hope this is understood. So that is done. Only tail pointer is increased. Okay, now if we want to add 20, we want to add this 20. So the same thing happens. It first check if it is what? If it is filled. It realizes that it is not filled because tail pointer is no more than the maximum value. Then it checks if what? If the queue is empty. Is the queue empty? It saw that TP is not equal to 0. Then what happens? It adds the value to array TP. And what is the tail pointer? Which is now 2. So it now adds 20 to that position. So this becomes 20. I hope this is understood. This becomes 20. So this can no longer be tail pointer. So this must now be the tail pointer. So it satisfies this tail pointer is equal to tail pointer but 1. So that means we need these 3 codes to be able to what? To be able to enqueue. Check if it is filled, check if it is empty, and check if it is not empty. So with this 3 code, we can successfully put all this value into the queue until it is filled. And when it is filled, it writes queue is filled. So I hope this is well understood. So let's implement this in the Python code. So the question states, the procedure enqueue takes a string parameter. So which is exactly what we have done. Enqueue, the string parameter is word. If the queue is full, so we say that if the queue is full, that means if what? If the tail pointer is what? Greater than, is equal to 15 or greater than 49, because we have 50 spaces, which is 0 to 49. So we can say equals to 15. We can also write greater than 49. Both are correct, okay? So if the queue is filled, the procedure output is suitable message. Then it prints the queue is full, no space to add new value. I hope this is understood. So back to the question. The question states, if the queue is not full. So with this statement, it is if the queue is full. Now, if the queue is not full, okay, so that is else. Insert the parameter into the queue. So can you see that this question is quite different from what I explained initially for my illustration? My illustration is to make you understand what a queue is. But with this question, you need to follow what the question is saying and answer the question as the question have said it, so that you don't waste your time and you don't add extra things to your code which might make you make more mistake. I think you understand. So I've explained what a queue is, how a queue operates, or the function of a queue. But when you are answering question, you answer the question according to what the question has written. So the question says check if the queue is full, which is exactly what we have done initially. It's now saying if the queue is not full. the position inside the parameter into the queue. So inside the parameter. So then we write this as q dot append. Then wait inside the parameter. That is what the question wants. So don't try and say, is it empty? Is it not empty? The question does not want that. But we are going to do that now. Okay. Now, so we have inside the parameter. So the question now says update the relevant pointer. So that is where we now need to update it if it is empty or not. So how do we update the parameter? So we need to check if the queue was empty or not empty. So this is what we need to check. So we have append the word. When you use the function append, it will actually put the new value into the next available position in the list. So that is why we need to worry ourselves about where it's going to put it. It's going to put it in the next available position. I hope this is understood. So then we check if tail pointer, okay, is equal to -1, meaning that was it empty initially? If it was empty initially, then we write that tail pointer is equal to 0. Then we make it 0. I hope this is understood. If it was empty initially, then we'll make it 0. Oh, sorry, I mean head pointer, not tail pointer. Head pointer. Because if it was empty, the value of head pointer will have been -1. So if it was -1, then we'll make head pointer to be equal to 0. I hope this is understood, because if it was empty, the value of head pointer would have been -1 and the value of tail pointer will be 0. If it was empty, the value of tail pointer was 0, right? So we need to add +1 to it to make it 2. So we are not following this line of code the way I explained it here, but we are following it according to what the question has said. But I hope you understand what I wrote here and you also understand what I'm writing here. Okay, so after doing that, then we increase the value of tail pointer. Then we write that tail pointer is equal to tail pointer plus what? Plus 1. Or I say tail pointer plus equal to 1. So it means the value of tail pointer has now been increased to 1. So with this few line of code, I've also achieved everything I wrote here. Okay, with these few lines of code. So just write the code the way you understand. So the most important thing is understand how a queue works, and that will guide you on how to write your code. Let me check this again. If this is 50, means it's full. It means it's full. If tail pointer is not 50, that means it is not full. It append word. And appending word means put word in the next available position. Is that understood? That is what append will do. So if head pointer is equal to -1, it's checking if it is empty. If it is empty initially, head pointer will have been 0. So if it was empty, then set head pointer to be 0, meaning there is now a value in the first position. After doing that, then increase the value of tail pointer. I hope this is understood. Okay, good. So let's move to the next one. The next one now says that the function dequeue. The function dequeue. df dequeue. Okay. Checks if the queue is empty, so it requires no parameter. So move on. But before we move on, don't forget that we are using the global variable in this function and we need to redeclare it. Don't forget. So we need to redeclare global queue and also global head pointer, global tail pointer. If you don't understand the reason why we need to declare, check the first video. In the first video I uploaded on YouTube on Cambridge exam, I explained the reason why we need to declare them one by one. Okay, good. So now that we've declared them, then we should have no more issue with this. So the queue as well checks if the queue is empty. So I still need this variable back. So let me redeclare them because I will need them in this function as well. Okay, so it checks if the queue is empty, because you cannot pull out from an empty queue. So the first thing to do is to check if the queue is empty. And how do you check if the queue is empty? You check if what? If head pointer is equal to -1. Remember, if head pointer is -1, that means it is empty. The function outputs a suitable message and returns the string empty. Excuse me. So that means that you have to print the queue is empty. It's now saying return what? Return the string empty. Then return, oh sorry, not there. Then return empty. So it returns the string empty. So that has been answered. Okay, so let's move to the next line. If the queue is not empty, that is else. Okay, the function returns the first element in the queue. Returns the first element in the queue. So that means it returns the first element. And where is the first element? So the first element is the index, is the value in the array at the index of the head pointer. The first element is the value in the array at the index of the head pointer. So that means if head pointer is 0, the first element is at index 0. That is what it means. So you return the queue of head pointer. So I hope this is understood. So after doing that, the question now states that update the relevant pointers. Okay. Now, when you have sent out the value from the head pointer, so this is the head pointer. Okay. Now you are dequeuing. You have taken out this queue now. You have taken out this value. Okay. When you take out this value, do you know that this is supposed to be the first value since 5 has left? Just like when I said some people are on queue to get a service, the first person has been serviced or the first person has been attended to. The first person needs to leave the queue. Then the next person becomes the first person. So because this 5 value has been taken out of the queue, then this value now becomes what? The head pointer. So that means that the head pointer will now be equal to head pointer plus 1. I hope this is understood. But for the array, you remember we are using array to represent the queue. So this is the value in the queue array. This 5 did not leave, although it was returned. Is that understood? It's still in the array. I hope this is understood. It is still in the array. But from the actual queue, so it has left the queue, but it is still in the array. So when you increase the value of head pointer now points to what? To 15. So this now becomes the head pointer. I hope this is understood. So 15 again, when you take out 15 again, okay, when you take out 15 again, you are supposed to increase the head pointer so that it now points to the next available, next first element. So, like I said, so you need to increase the head pointer, okay? So since you've returned the queue of head pointer, then you write that head pointer plus equals, okay, plus equals to 1. I hope this is understood. So let's take a look at it again. If head pointer is -1, it means the queue is empty. We are very sure of that, right? So the question says if the queue is empty, the function outputs suitable message and returns empty. So the message has been outputted and this has been empty. Okay. Now, else, if the queue is not empty, the function returns the first element in the queue, which is the element at the head pointer. So it returns queue of head pointer. Now, the function returns the first and update the relevant pointer because head pointer should now go to the next position. Is that understood? So that means the question has been answered. um, update relevant pointer. So that means you need to increase the position of the head pointer since one item is out of the queue. Okay. Now, can you see there is a slight issue here? Head pointer is grayed out. What does that mean? When you write a function and it executes to the point of return, to the point of the keyword return, keyword will return. What does this does? It means that it will exit the function. So this keyword return means the function will be exited. It will get out of the function. But we want it to execute this as well. So this will not be executed because when it hits return, it gets out of the function. So that means return should be the last thing that should come in this code. So that means I need to take this away from here and add return qf pointer after that line of code. But still, this will be wrong because we are supposed to return the element in the first element in the queue and not the next element. So look at this point. We said head pointer equals to head pointer plus 1. 1 has been added to end pointer. So returning queue of head pointer means you are returning the element in the next position because head pointer has been increased before you now return queue of head pointer. So what I'm supposed to do here is return head pointer, queue of head pointer minus 1 so that this still returns the previous value, although value of head pointer has been increased. I hope this is understood. Okay, good. But there's something. Let's check our code again. If head pointer is empty, print q is empty. If it is not empty, then we say head pointer is equal to head pointer plus 1. We increase the position of head pointer, that is, we change it to the next position, but we are returning the q of the previous head pointer. Okay, that means if head pointer was 0 initially, head pointer is now 1, but we're returning the q of what? 1 minus 1, which is now 0. Returning the q of the previous head pointer. So the item will get out of the array if we want to pop out another item from the queue. So let's take for example the queue have elements 5, 7, 9 initially. This was the head pointer initially, isn't it? So when you pop out 5, we increase head pointer to the next position. So 5 has been popped out. Is that understood? Then when we pop out 9, then we increase the value of the head pointer. So this becomes the head pointer. Then when 9 is popped out, then what happens? The array is now empty. Then head pointer will be increased, then it will be here. It will be at this position. So this becomes head pointer according to that code because head pointer will be equal to head pointer plus 1. Is that understood? But remember, this was the tail pointer. Okay, because tail pointer was pointing to the next available space. So this was the next available space that the tail pointer is pointing at. So because we are popping out of the queue, head pointer kept increasing. So that means that when head pointer get to this point, it will be equal to tail pointer, which means that this queue is now empty. So when you pop out item out of the queue, it will get to a point that the queue will be empty. If the queue is empty, do we still need to pop anything out of this queue? The answer is no, because there will be nothing left in the array. So that means that there will be nothing left in the queue. Is that understood? In the memory, there will be nothing left in the memory. So that means that as you pop out your value and increase your head pointer, we don't only need to check if the queue is empty, we also need to check if the queue is we don't yes we don't need to let me rephrase it again. When we want to check if queue is empty according to this code, we said that if head pointer is -1. So when head pointer is -1, it is empty, which means there is nothing. Is that understood? There is nothing. So this is the condition that says that there is nothing in the memory. But when we start pumping, if there is something, so we start popping it out, isn't it? We start popping it out and increasing the index of the head pointer. It gets to a point that there will be nothing again in this queue. Do you understand? Apart from the first condition. So in this point, head pointer is not -1 because there was something initially. We kept increasing head pointer. Is that understood? So in this case, head pointer will be equal to what? Tail pointer. So when this occur, then the queue is now empty again. Although it wasn't empty initially, but now it is now empty. Is that understood? So while checking if the queue is empty, this function actually check if the queue was empty initially. So or head pointer is equal to tail pointer. So this function will now check if the queue is empty while the item is being popped out of the queue. Is that understood? So we need this statement to check while the item is popping out. We need to also check if the queue is now empty. This check if the queue is first empty. So before we start popping, that do we need to, can we even pop something out of the array or of the queue rather? Is that understood? So if the queue is not empty, it starts popping out. If you call the function again, it pops out. Call it again, it pops out. It gets to a point that head pointer will now be equal to, will now be pointing at the empty location, at the next available location. And at that next available location is where tail pointer was already pointing. Is that understood? So we need these two conditions to check if the queue is empty. Is that understood? So this is the end of the code for the queue, which has answered the question. I hope this is understood. So let's move to the next question. The next question now states, a shop sells computer games. Each game has a unique identifier of string data type. The text file qdata.txt contains a list of game IDs, which is the identifier. The procedure, read data, reads the data from text file. So we need another procedure called read data. It reads the data from what? From the text file and insert each item of the data into the array queue. Write program code for the procedure read data. So let's try and understand this. Queue data is a text file that contains IDs of games. Then we write a procedure, a function for read data. Is that understood? So let's write the function. So the function is def read data. Okay. So what does read data does? It reads data from the text file. So before you try to read, let's load in our text file to the Visual Studio Code. Let's load in the text file into Visual Studio Code. And how do you do it? So you go to the location where the source file is stored, where your file is stored. So this is where my source file is stored. So you can see the qdata.txt. So I saved the data is saved in my desktop. So I open back my Visual Studio, then click on this Explorer, open folder, okay, then go to desktop. So you can remember this was the folder where the text file is saved in, okay. Then click on select folder. So save, because I did not open it initially, so it's trying to close my Visual Studio Code. So that is the reason why you need to save always, okay. So let me save now, and my file is now here, okay. So since my file is now here, so I need to do is to open back my code, okay. Then click on open file, then locate the code where it's saved, okay. So now I've been able to open back the file, okay. Okay, so now you can see that the qdata.txt has been opened. So that is the first thing you have to do. So probably when you see an exam question that you need define, make sure the folder is open before you start writing your code. Or if you need to open later, make sure your work is saved because the Visual Studio might get closed. That is if you use Visual Studio Code. So I can collapse this file explorer. And the question states, a text file contains the procedure is this procedure, that is this function, okay, read data, will read data from the text file and insert each item of data into array queue. So first and foremost, let's read data from the text file. And to read data from the text file, so in case the data, we can use try and catch just to write a try function so that in case data does not exist, then it doesn't return an error. But it is not compulsory because this data exists. Is that understood? But I like using try and catch so that in case data does not exist, it doesn't return an error. Then we start with open, then the name of the data is what? QData.text. Okay, QData.text. So you can open as read. It's the same, or you don't even write anything. By default, it is read. Then as let's say as file. So that is the object that will handle the data, the file data. Okay, the text file. Then after opening this, the question says read. The procedure with data reads data from the file. So you can't read the data, you can't read a file except you open it first. So now that it has been opened, then we can read the data. After the file has been opened, then we read data from that file and insert each item of the data into the what? Into the array. So as we are inserting each of the data, that means we need a for loop to what? To take each of the data from each line. Is that understood? Each of data for each line and put it into the queue. So when you want to put an item to the queue, don't forget you need to use the function enqueue. Is that understood? You need to use the function enqueue. So we want to read each of the data and save it into what? Into the queue, array. So to read the text file into the array, like I said, you need the enqueue function because the enqueue function will what? Will read the word, will add whatever word or whatever string into the array. So like I said, since we have a lot of things in the text file, so we can read it in line by line and save it into the what? Into the queue data. So I use the for loop. So I write for line, like a variable line in file. Okay, that is, it will take each line in the file that has been opened. Okay, that has been opened. Then I write enqueue line dot strip. So this will strip out any the special character. Then it will be passed into the function enqueue. And remember the function that we wrote. So it populates what? The array based on the function that has been written. Okay. So now that this is done, then we write except because we're trying to open the file. If the file exists or not, it tries to open the file. If the file could not be opened, then it throws an exception. Okay, except exception as, let me say, err. Okay, then I print err. So this will print whatever error if the file could not open or maybe the file does not exist. So that means the question has been answered, okay? Because it says the procedure reads data, read the data from the text file and insert each item of data into the array. So which is what the enqueue function does. So I only need to call the enqueue function and pass each line to the enqueue function. Okay, so this is exactly what the question wants us to do. So question C, question 2C.